Hi everyone, welcome back to my YouTube channel. In this video, basically what we'll be doing is we'll be continuing from where we left off in the previous video, and we'll be basically showing 3D models instead of just a cube, and we'll be adding hit testing support as well. Basically, what does hit testing in the simpler terms is like whenever you see the reticle in the screen, and whenever you tap on it, you'll be able to place the models in the real world. Just to be very clear, what I mean, we can see the video together. As you can see, user can interact with the model and he can click on start AR button, and you can place the basically the models wherever the reticle is there. Okay, that is it for this video, and that is it for this demo video. Okay, and we'll start with the code part. Okay, for one more thing, for simply just for convenience, I have downloaded some models from this site called PM, basically this site, and you can see the different models available, low poly models. Okay, so if you would like to download any other model, you can just click on a model and download a model, and it's just going to give you a GLTF model. And I just rename those models and them in the public directory in the models folder. Okay, that is it, and I'll just minimize this. I think like how I told you previously, I'll be creating different components for every video. So for this one, I'll be create different folder itself just for convenience. Okay, and I'll give the name as xr model dot view. Okay, and I need to come to the router index.js. xr model. Okay, and hit test. Okay, and save. Okay, now let's copy again like some of the at least boilerplate code from the previous video. Okay, and in this video what we'll be doing is like we'll be first importing the models. Okay, and then we'll be basically showing those models in real world. So for importing the models, what I'll do is like I'll use something called GLTF loader. One second. There are different kinds of extensions. Basically the 3D models are available in different extensions, and there are different loaders available in Three.js to load different kinds of models. For GLTF model, we need to have a GLTF loader. Okay, so I'll be doing that. GLTF loader. So I need to use the loader, and one more thing is like I'll create some variables in this place itself. Let's show model, let loaded model. Okay, and let model name. I'll be using the taxi model for this video. Okay, and we need to come to the mounted. Okay, in the mounted we need to basically load the model. Okay, I don't think it's going to be required in other places, so I'll just declare here itself. Okay, and then I'll be calling the method gltfloader.load, and I need to pass the path, okay, which is nothing but slash models slash model name. Okay, and dot gltf, the extension. And whenever we get the model, basically whatever we get the response after loading that model, we'll be assigning it to the loaded model property which we have declared in the top, and we'll be assigning it something called gltf dot scene. By the way, I'm not explaining a lot of stuff behind the scenes what goes, okay, with regards to model as a whole, why I'm using gltf scene or children and all. I've already done that in my previous playlist. I would suggest you to check that out if you're anyhow somewhat lost, okay. Anyway, I've loaded a model, okay. Now what I can do is like I'll assign it again to shown model, okay, and this shown model will be shown instead of the cube, okay. So what I can do is like I can have the loaded model dot, no, one second, I'll just do one thing. I'll pause it till here, okay, and we'll just see whether any errors are there, okay. And before that, let me remove this cube, okay. We don't need the cube now, okay, in this scene, okay, and let me run it. Let me close this terminals. Okay, so let me copy it. And /xr model. Let's see whether we have any errors. And as you can, okay, I need to remove that loop also. This should work. Okay, the box error is gone. Now as you can see, let me refresh it. Why? Okay, scene.endbox. Let me refresh it now. As you can see, there's something been error coming up from gltf loader. It's saying 3.gltf loader, no Draco loader instance provided. So just as a explaining brief, basically what is happening is like whatever model we're using, it's compressed using something called Draco compression, okay, and we need to first decompress it and then use it in our scene. So for that we need to do something a little bit. We'll basically need to tell Three.js to use the Draco we need to tell Three.js to use the Draco loader in simpler terms I would say is like we need to use the Draco loader library to decompress the 3D model and show it in a 3D scene, okay. And again I would suggest you check out my previous playlist, okay, if you get confused. Anyway, for this one we need to first go to 3 directory folder in the node modules, okay, and I think it's here. We need to come to examples JSM libs, and we need to copy the Draco folder, okay. I think it should work. Copy, minimize, let me come to public, paste. Yeah, as you can see we have the Draco folder here, and we need to tell the gltf loader to use this Draco library as well as the Draco loader to decompress the model, okay. Some extra stuff we need to do, that's it. Anyway, it's just one time setup, so I think it should be okay. Draco loader equal to new. Okay, and I guess it doesn't import, not sure why. Why is it not populating automatically? Okay, sorry. Yeah, it should populate. Okay, and we need to instantiate the Draco loader, and we need to tell Draco loader where the library is there, okay. Basically whatever folder we downloaded, we have put in the public, we need to tell the Draco loader where is it. So Draco loader dot set decoder path slash Draco slash, okay, and then we need to tell gltf loader to use it. gltf dot set loader Draco. Okay, let's see first whether the error has gone or not, okay. And as you can see the error is gone, okay. So I think we're good to go. Okay, and I'll just continue where we left off in here. Okay, so we have the loaded model. Okay, now we want the shown model, okay, to be assigned a copy of the loaded model. Okay, basically having a copy of the model. Okay, and we would like to add that model to the scene using shown model. Okay, and one more thing is that we can add a name also to the shown model dot name equal to, and we already have a variable declared on top, name, model name. Let's see something happens or not. Okay, and as you can see, the car has come out, but it's quite big, so I'll just reduce the size of it using scale property 0.5. I'm making it half in all the axes. Let's see how it looks now. I think this is looking good now. Okay, this should be enough. Okay, now we'll do one thing. We'll be adding, like how we have the cube rotating, we'll be adding the rotation for this also. So for this little bit, we have to go another way. Okay, a different way, not like how we have done exactly like cube. Okay, so what we'll be first doing is like we'll be checking whatever is in the scene. Okay, scene's children's. Okay, scene dot children. Then for all the children's, okay, we'll check if that's object present as part of the scene's name is equal to model name. If it is, then only we'll rotate the model around the y-axis. Just to be on the same page, let me do one thing. I'll just do console.log object. Okay, let's see. As you can see, the taxi is rotating, and you can see there are different stuff coming up now: ambient light, perspective camera, object 3D, and all. But we want to just rotate the taxi, so that's why we, as you can see, object 3D has the name of taxi, and that's why it's rotating only that. Okay. Anyway, I'll just remove this. Okay, now, so we have the basically 3D model of the loaded in the web scene. But now let's see. At present, we don't have much. We have this taxi in the air. So first of all, let me do one thing. Okay, let me not show this taxi which we are showing in the normal web 3J scene when we are in the air experience. Okay, basically when the Webxr session has started. So for that, what we can do is like in the loop only, we can check for something called if renderer. Okay, it's provided by renderer on again dot xr dot is presenting. That means whether we are whether an webxr session is already running. In that scenario, I just don't want to show that model which we are showing in the 3J scene. Okay, let's see now whether first of all whether we are able to hide that car or not in the AR scene, in the WebXR session. As you can see, the car is gone. Okay, but anyway, we need to again, like how we have seen the video, initial part of this video, like the demo. So we'll be need to have the hit testing support and show the model and the reticle as well. So first of all, now let us come to adding reticle and the hit testing support. So for that, let me do one thing. I'll create a variable called reticle, and I'll be adding some more variables which will be the use case of these variables will become clear later. Hit test source equal to null, and let hit test source requested equal to false. Okay, now let me create a reticle. I'll just add it below the camera. I think it should not matter much. Sorry about that. And I'll be using something called new 3 dot mesh I'll be using a different geometry for this. I'll be using something called ring geometry. Okay, and I'll be passing it some values which are experimented before. You can change these values and customize later on. Okay, and let me give it a color as well using mesh standard material. If I don't give it a value, by default it will be white. That's okay, I guess. Let's first see what happens. Okay, like I told you previously in one of the videos, we need to add it to the scene also. As you can see, we have the reticle here, and I don't want it to be positioned like this. I want it to be rotated. So what I'm going to do is like somewhat change its rotation. Let's see, now I think this look good. Okay, so yeah, and now what you have to do is like some of the things will be disabling or enabling on reticle. Okay, first of all, we'll be disabling a property called matrix auto update. Okay, the thing is with regards to Three.js is that whatever we are doing with all this mesh and all this manipulations and all, behind the scenes we are using, behind the scenes Three.js is using matrices to keep track of it. Okay, I'll not be going too much in depth in that part, but basically when you do matrix auto update equals false, that means we're telling Three.js uh, not to modify properties of this reticle, because we want to do it customized. We want to do it by ourselves. Okay, basically we're doing that through this line of code. And let me make it visible as false, because I don't want it to be shown in a normal Three.js scene. I want it to be only be shown in the AR experience. Okay, let's see now. It should be gone. Let me refresh it once more to be very clear. As you can see, that is gone. Okay, now let me come back. Okay, as you can see, we have already loaded the model. Okay, gltf model, and so now we have to come and ask Three.js for the hit testing support. Okay, and that we have to request, basically we have to request a browser or user agent, you can say, for the hit testing support. Okay, so for that we have to come to the where we have declared basically document.body. Okay, and we need to tell that we need to tell the browser that we want hit testing support. Okay, so required features colon hit test. Okay, and that is it for the this thing. Required features, yeah. When we say required features, we mean like we're telling browser that if you're not going to provide us the hit testing support, we'll not be running this experience itself, so that uh, it becomes very clear to the user as well as the browser, like this experience requires hit testing support, otherwise it's not going to work. Okay, there is something called optional features also, which we'll be exploring further in one of the videos going ahead. Anyway, required features will add the hit testing support. Okay, now let's see. So we added the hit testing support. Okay, now we can come to the main part of this video. Basically, what we'll be doing is like, first of all, let me add some stuff here. Okay, we which I not added previously because it was not required. We'll be adding timestamp and frame. Okay, this frame is the thing which we'll be using a lot in this video. Basically our whole experience depends upon it. Okay, so this frame will give us so we're gonna write the logic whenever we're basically gonna execute the logic only if the frame is present. Okay, so we'll be first getting a reference space from the renderer. uh, Reference space, and we'll be getting the session also from the renderer, Webxr session, by the way. So just letting you know what is this. Okay, actually, first of all, get session. So first of all, what is this reference space? I frankly say I'll not be going too much in depth about what it means and what it entails with regards to AR, VR, and XR. But just for this video and for this playlist, I would be telling in short is like you can imagine the reference space as a 3D coordinate space system. So and we would be basically manipulating stuff with from one coordinate system to another coordinate system or one reference space to another reference space. It will become more clear while we write the code. Okay. So anyway, we'll be having the Webxr session and we'll be getting through this render.xr.get session. Okay, now we'll be first checking, okay, whether we have we already found the hit test source or not. Okay, for that we'll be first checking whether hit test source request is equal to false. That means by default it's going to be false. Then what we're going to do is like we're going to request browser. We're going to request from the session that we need the reference space, and we'll be needing the viewer space, which is very much useful for our which is very much applicable for our AR scene, AR experience basically. There are different references again, we can explore it later in future, but for this video and playlist it's not needed. Okay, and so I'll be getting the reference space. Okay, and again I need to call session request uh, hit test source, and I need to pass this space, this reference space which I found, which I got just now in the first line, and this I'm basically passing this reference space here. Okay, and when I find it, okay, then I need to again basically when I get the hit test, this is again going to return a promise, so again I need to handle it, and it's going to give me the source, hit test source, which I'll be assigning it to the hit test source variable. This is a lot of setup, frankly saying, but it's in one. This is the main setup. After that, we don't need. After this, we'll just try to do more setup. Then I think it's not required. Okay, anyway, first of all, like we got the hit test source requested, so we don't want it to be executed from next time onwards. This snippet of code, so we'll make it true, since we already found the hit test source. Okay, and by the way, what do you just as a simple analogy, you can say like you can imagine like from your mobile, for each whenever you point your mobile to the your environment, basically from your mobile center, okay, a ray is being passed and it's intersecting with the whole environment. Okay, and those places where it's intersecting are those hit points or where the reticles are being shown. Okay, so we are going to be placing our reticles on the places where we get intersections from the ray and from the environment. Okay, so and whenever and there are chances where that hit test source sorry where there might not be any hit test results, basically where there might not be places where the ray which was passed from the center of your mobile had intersected with environment. Okay, and those frames basically will not be showing the reticle. It will become more clear while we write a code. Okay, and anyway we'll be adding a different event listener. Okay, whenever this session ends, okay, we would like to go to default values, assign the default values to hit test source requested, which will be false, and hit test source, which will be null. Okay, this is it. And now let us come, if we find a hit test source, okay, basically, and if we have found a hit test source, so we are assuming we'll get some hit test results as well. It's not always we are going to get the hit test results like I told you previously just now, but anyway we might get hit test results. Okay, so we have to handle it. So from the frame we'll be getting hit test results. Okay, and we need to pass the hit test source to it. Okay, and if we have hit test results, okay, basically if the hit test results length, it's going to be array. Okay, and if its length is greater than 0, we'll be doing something, and if its length is not greater than, we'll be doing something. Okay, let's write what we'll be doing that something. Okay, so first of all we'll get the one hit point or hit intersection in the 3D space. Okay, which will be we'll be taking the first one, which is the 0th element, and we'll be making the reticle as visible, since we found a hit test location where the ray has intersected with the environment. We'll make the visible as true, and we need to find where we need to find a location where we need to put the reticle. Okay, for that what we'll be doing is like we'll be having the reticle dot metrics Like I told you, we can use the metrics to manipulate the objects measures directly. Okay, and we'll be having something called from array method on it. Okay, and for that, what we're doing, we'll be taking the hit test hit uh, location. Okay, and we'll be calling something called get pose on it, and we'll be passing the reference space. By this reference space is this one. Okay, just to be very clear. Okay, and we'll be having a variable called a property called transform on it, and we'll be having the metrics again from here. So just in simple terms, what is happening is like we got the hit and we get the pose. Pose is nothing but the six. You can say the 6 degrees of freedom of that intersection point in this reference space. Okay, what we want. Okay, because this is the reference space which we are having. Okay, so you can, like I told you previously, like we are basically manipulating from this coordinate system to another coordinate system. Okay, in simple terms. Okay, so we get the hit location of the 60, basically the rotation as well as the orientation. Okay, you can imagine a space, basically you can imagine an astronaut in the space. He has different kinds of orientations around in the xyz axis, as well as different positions in the xyz axis. Okay, um, anyway, so we get the hit we get the what should I say, the position in the 3D space in the with regards to this reference space or this 3D coordinate you can imagine, and then we are manipulating the reticle to be placed on that location. And suppose in some frames we don't find the hit test results, on that scenarios we just don't want to show the reticle. Okay, instead of just showing it randomly in so many locations, we'll just not show itself. Okay, this is it, I guess, and I think not completely I feel, but this part is done. Okay, the hardest part I felt. Okay, and okay, this is done. Now one more thing is like I'm coming to the mounted part. Okay, so so we have written logic in for per frame. Okay, what has to be done for per frame. Okay, but the thing is like we have not written any kind of logic for the scenario where basically how and when we are going to place those models. Okay, like when do are suppose we should, the reticle is visible in the AR environment, but how are we going to place the models? How would the browser know when to place the models? Okay, and basically, okay, so for that reason you can basically, I think you might have understood till now, like I'm talking about like this touch inputs. Okay, so we have something called controller. Okay, and we again get it from renderer. Okay, and when I'll not be going too much deep because there are different kinds of controls available, but I'll for our terms we can say like this is a touch input. Okay, the first when we give 0, okay, we get a handle on the touch inputs done on the screen whenever the user is in the XR session. Okay, and I would be listening on a event, okay, which is called select, and I'll be calling this function. Okay, let me check once more. I'll have missed it. Render.xr.get controller and controller.add event listener select on select. Okay, now what we're going to do is like whenever user touches the screen, okay, in the AR session, we'll be calling this on select method. There are different kinds of events as well, but for our sake I think select is more than enough. Okay, so we'll be calling the on select and we'll be checking first. Okay, there will be three things we'll be checking, two things we'll be checking. We'll be checking whether the reticle is first of all visible or not, and we'll also be checking whether we already have the model or not. Okay, and if we have it, then we are going to create a new copy of the model. This is a clone. Okay, and we'll be giving it a name of, you can avoid it or give it, it's up to you. I'll just give it to make it different from the one which we already have. Okay, and then I'll be assigning the position of this model, okay, based on the reticle's position. So set from matrix position, and I'll be putting taking the reticles matrix, okay, model at position, and I'll be giving it a little bit less scale, okay, 0 0.3, 0 0.3, 0 0.3, and I need to add it to the scene. Okay, and I think this should be enough, I guess. I think I did not miss out anything else. Okay, we can anyway check it once if I missed out anything. Okay, let's refresh it. Let me click on it. Let me zoom it down. As you can see, the reticle is there now. I'll be placing the model using right click of my mouse. Right click. As you can see, the car has been placed. I can again rotate the mobile and right click again. As you can see, one more car has been placed similarly, and that's it, I guess. And let me see. Sorry about that. I don't think I've missed anything. Um, no, I don't think so. Yeah, it's working fine, and if you'd like, we can rotate the car also, but I'll just keep it like this, stationary. Okay, and yeah, let's deploy this. Okay. And by the way, just to be on the clear, okay, what happened? Just a brief overview of what we have already done. Okay, we found the hit test source. Okay, we found the hit test results. We got the hit test results. Okay, and we show the reticle on those locations. And whenever a user taps on the screen, we are calling this function on select, which is basically placing car models on those reticle locations. Okay, in simple terms, basically the brief overview of what we've already done. Anyway, let's see whether it's deployed. Let's see. I'll refresh this part. Come here. XR model. As you can see, we have the model here. Let me click start AR. This is a live site. Right click, right click, right click. Okay, it's working fine, I guess. So this was the end of this video, I guess. And I'll be seeing you in the next video, and where we'll be adding, we'll be seeing how to add HTML elements to the AR experience. Okay, using DOM overlay. Okay, I hope to see you there, and thanks and bye.